Tutor Polly here, back with Calculus Integrals U substitution. We have this expression here in the dark green, and our goal is to find a u and its derivative. So find an expression and its derivative in this expression here, and we're going to transform this integral into a much easier integral to integrate it. Note that it's kind of complicated, right? There's a function times a function that's an x times an a to the x, some number to the x. Well, what we're going to have here is that you're going to be off by a number. I see the negative x squared, and I see something that could be close to its derivative, but we're just off by a number. That we can fix. So the first step is to pick u. So our u is going to be negative x squared, because I know if I'm to differentiate u, okay, because the next step is to differentiate it and get du, then I'm going to get negative 2x dx. Well, I see the negative x squared, and I see the x, okay, that's something more foundational, right? That's an actual function. I don't see the negative 2, but you know what? We can fix that. So what we're going to do now is to solve for dx and get dx alone. So dx, we're just going to divide by the negative 2x, and we get dx equals du divided by negative 2x. Well, now it's u substitution, so substitute in. We're going to replace the negative x squared with u, and we're going to replace the dx with du over negative 2x. Now, we can't have both x's and u's. Well, look what happens. The x's cancel, dx is no longer there, notably as well, and we're just left with this negative 1/2. That is okay. All right, well, we're going to bring that out of the integral because you can. And now we have a totally more simple integral just in terms of u. All right, we've transformed this. Well, the next step is to understand how to differentiate something of a to the x, any number to the x power. Well, the derivative of a to the x is a to the x ln of a. So if I had 2 to the x, that's 2 to the x ln of 2 to differentiate it. Well, look, if we were to differentiate 4 to the u, we would get 4 to the u times ln of 4. But we don't have an ln of 4 in our expression. So think about what can I differentiate in order to get this expression here. All right, well, it's going to be off by an ln of 4. So what are we going to do? We're going to divide this expression by ln of 4. And now the framework, a to the x, of course, that's still there. Well, return to x's. Okay, we've integrated it. Now we can go back to whence we came. We started with x's. We shall return, and we replace the u with negative 2x. If you were to differentiate this thing, you would get what we started with, and that's how you know if it's correct or not. And so next step is, hey, you can do the reverse power rule with exponents, logarithm, and natural log properties. So this is what I call throwing up. You can throw them down, exponents. You can also throw them up. So we throw up the 2 to ln of 4 squared. So now it's ln of 16. And that is all.